Hello, welcome to my channel. We will be doing question number 5 right now. Okay, so question 5, it have two parts. It's fairly simple question. So part 1 says we are given a curve y equals x minus 3 times log of 2x square plus 1. So we need to find in part 1 the derivatives dy by dx at x equal to 2. So first of all, we will find dy by dx. We will use quotient rule. So this is first function into derivative of the second function. Log x is something over this thing, this whole thing, 2x squared plus 1 into derivative of this part, which is 4x. Okay, plus second function, which is log of 2x squared plus 1 into derivative of the first function, which is just 1. So we will simplify it a little bit. It's going to be 4x times x minus 3 divided by 2x squared plus 1 plus log of 2x squared plus 1. Okay, now we need to evaluate this derivative when x is equal to 2. So I will substitute 2 for x. This is going to be 4 times 2 is 8. And 2 minus 3 is minus 1. And 2 times 2 is 4 times 2, 9. This is 9 plus log of, again, 2 times 2 is 4, 8, 9. Yeah, this is 9. So we can write it as log of 9 minus 8 over 9. And if you want to find its numerical value, that is going to be 1.308. Okay, now the second part says that we need to find the approximate change in y when x changes from 2 to 2.03. Okay, so basically we want to find the approximate change in y. So this is dy by dx into delta x. Okay, and I will explain you why are we using this thing. Okay, now dy by dx at x equal to 2 was, if I write the numerical value, it is 1.308 multiplied by, what is delta x? Delta x was, remember, x changes from 2 to 2.03, or this one. So from 2.03 minus 2, so this would be 0.03. So sorry, I don't remember it. Okay, so multiply by 0.03. So when I multiply them together, I got the answer as 0.0393. Okay, so the idea is, if I have a curve, let's say this is the shape of the curve, and I know the value of the function at this point, and I know the slope of the function at this point. So if I want to find, if x changes from here to here, for example, so this is delta x. Okay, so exact change in y is, of course, I need to find that we go from here to here, right? So exact change is from here to here, okay, right? But approximate change is from here to here. I can see that, okay, and if delta x is really small, then this approximation is a good approximation. Okay, so instead of using the curved path, I will use the straight line approximation of it, and I multiply this slope with this delta x, and I will get this delta y. Okay, so this is the idea behind this relationship. Okay, I hope it's clear. If you have any question, you can always ask me in the comment section. See you in the next video.